Hi, welcome back to Tech TV. I'm Scarlett Evans. I'm here with Kaushal and Nalin from Renesas. Kaushal, to start off with, tell me a little bit about your company.
Sure. Yeah, I mean, Renesas is one of the leading semiconductor companies. We make chips, pretty much everything from digital compute devices like microcontrollers and microprocessors that basically cater to the edge and the endpoint of the IoT network. And then we also make mixed signal devices, timing devices. So we have a large portfolio of hardware components, both programmable and analog mixed signal that serve the IoT market, right? Our company primarily focuses on automotive and industrial as a couple of our key strength markets. That's where we're looking at applications of AI, and how they can help with several of the use cases related to machine learning in industrial environments and things like that.
So, was it a relatively recent addition that you started including AI and machine learning into your technologies?
Right. So we're traditionally a semiconductor company, but recently, earlier this year, we acquired, Reality AI, which is our, first acquisition in the AI machine learning software space. Nalin can talk a little bit about Reality AI, but essentially what Reality AI brings, to the Renesas family is it brings a combination of advanced signal processing and machine learning and AI at edge use cases specifically targeted towards automotive and industrial applications. And there are a couple of use cases that we will demonstrate to you today.
Before we get into the actual demonstration, I had a slightly broader question. But how are we seeing demand for these kinds of technologies changing? How has that trend changed in recent years?
Sure. There's this new term called AIoT, which stands for Artificial Intelligence of Things. So it's essentially where AI and IoT are coming together. And IoT traditionally has been a network of devices that are connected and business models evolving around connectivity in the network. What AIoT is doing is we're adding intelligence, or we're adding an ability to the devices to think for themselves. So we're technically moving from a more centralized cloud intelligence model to a more distributed intelligence model, where you're now going to see intelligence being embedded not only at the edge but also in tiny little sensors, whether it's your washing machine or it's an industrial pump or it's a car, or any application that you can think of. You can pretty much embed intelligence in real time. So to do things like inferencing, classification, or even quantitative measurements like predicting some failures and things like that, and detecting anomalies. There's just a host of different use cases how AI can be used, in these IoT applications. And there's data out there from IDC research saying there's about 73 zettabytes of data being generated by IoT devices. I don't even know how many zeros that has, right? So there's certainly a lot we can do with that data if you can act on that data right at the source where the data is being collected. And I think that's what makes the whole AIoT market and the growth in that market very, very strong over the next few years.
Amazing. And let's dive into the actual applications. So what do we have here?
Yeah, sure. We're showing a couple of different demos here, all pertaining to machine health applications. How we are able to look at signatures coming off sensor information from machines and do, for example, anomaly detection, predictive maintenance, and control feedback applications and such. So imagine, for example, you have consumer appliances here, like your washers, dryers, etc. We can detect things like your washer is anomalous while it's in spin mode, something's gone wrong, and inform the consumer immediately in real time, for example. Other applications such as making smart, self-aware HVAC systems, heating and air conditioning systems that can predict their own failures before they actually happen. So now I can inform the consumer, hey, you might want to get this serviced because we think there might be a certain problem with the compressor a couple of weeks from now. So you may want to get the service before it completely breaks down, for example, right? So all kinds of applications in consumer durables, industrial machinery, and automotive sensing applications as well. So this particular stack here is something you could imagine consists of components that you could see in an HVAC system today, air conditioning system today. It's got an industrial grade motor at the top. We've attached an air filter to the bottom and a damper here to intentionally simulate clogging of this air filter. This little device out here is basically an accelerometer, a sensor that picks up signatures from this entire stack. What we've done is collected data from this unit, put it through our Reality AI tools, which is our automated machine learning environment to create these machine learning models, and then deployed it back into an embedded microcontroller that's attached here, a Renesas MCU. The idea here is now we can look at signatures, vibration signatures coming off the stack in real time and predict potential failures or detect certain conditions of interest. So for example, we have 3 models running here. One's a classification model that's able to classify what's happening with this fan in real time. Is it blocked? Is it off speed, for example? We also have an anomaly detection model that will tell us if there's something abnormal that wasn't part of our training data set, but it's definitely a real outlier from normal operation, something that you might want to get checked. And finally, we're predicting the remaining useful life of this air filter in real time. So in a sense, we can tell the consumer or the service personnel that there's something wrong here or the filter needs to be replaced, for example. All this is done automatically by looking at the accelerometer data that's coming off the stack and the machine learning model running on the MCU to do that real-time classification. So I'm going to, right now the fan's off. There's nothing happening with the stack. I'm going to turn it on. And as I turn it on, you'll see we'll classify that's off, if it's off speed. And eventually it'll be fully up to speed and we'll say it's normal. I think you might be able to hear the fan. Just make sure it's running. There you go. Now, I'm going to try and clog this filter intentionally. So I'm going to block it halfway, for example. And you'll see immediately that we've detected that the filter life is now down to about 75% or so. Maybe even go down to 50% eventually. And that we've detected an anomaly. Now if I completely block this, we detect that the filter is completely blocked and we need to replace it. So all this is automated, just looking at the accelerometer data in real time, and the model is automatically detecting these conditions. Let me bring this back to normal, let it go back to speed. Now let me try something else, like maybe try and block this fan output. You'll see that we immediately detect that the fan is blocked. I'm going to turn off the fan. You see that it's off speed, going back to normal. So the idea here is now we can incorporate intelligence into all kinds of machinery, consumer durables, industrial equipment, pumps, motors, etc., and make these systems self-aware for predictive maintenance, control feedback applications and such. Here's another sort of demo that we're showing that revolves around motor control systems. So we have a Renesas RA62 motor control kit that's driving a small electric motor, a BLDC motor. And in this specific demo, what we're doing is we're looking at real-time electrical signatures coming off this motor without any external sensor components. So the idea here is looking at information such as current, voltage, phase error that's already available today to us from these motor control algorithms. We can detect if there's something wrong with the system, like it's an unbalanced load condition, for example, in your washer. So then the consumer can go in and say, hey, something's wrong with my spin cycle, I need to move my clothes around or something and balance it out or whatever it is, right? So we call this sensorless predictive maintenance. This is extremely lightweight machine learning. The model itself only uses about 9 kilobytes of flash, 20 kilobytes of RAM, and essentially the inference time is about 3 milliseconds.
So with all of these systems though, are they customizable for different use cases?
Yeah, interestingly enough, the way we customize this for different use cases is through our comprehensive development toolkit called Reality AI Tools. So customers are able to create a custom machine learning model for their specific application, whatever they want to predict or detect in their embedded system, without needing to be a machine learning expert to create these models. So they simply work with us to create a suitable, robust data set that can be uploaded into our software development environment and then goes through an automated machine learning process. What that means is they click a few buttons and we'll use our proprietary approaches to discover the best features in the data, tune parameters, and return a set of best fit machine learning models for their specific detection problem. And then there's a push button deployment to the Renesas MCU of their choice. So it's completely automated from data ingestion to model deployment and into the field.
That might nearly be all we have time for, but before we completely wrap up, what are you excited about for the future? What's next on the horizon for Renesas?
Really looking forward to integrating and making seamless integrations with the Renesas MCU portfolio of devices, the entire 16-bit to 64-bit core of families, right? We are basically supporting easy model development, validation, and deployment into any Renesas MCU or MPU of choice, which means we'll automatically be able to enable our customers to create smart, sustainable devices in the market, in products out there today.
Amazing. Well, thank you so much for your time. Thanks to the team here at Renesas. Thank you, Kaushal, as well. And yeah, that's everything now for Tech TV. Thanks so much.